Today I am going to tell you all about a blockchain project named Automata Network, and where the price may be headed. Here is what I am going to cover in this video. What is Automata? What is the price of ATA, and where can you get it? And lastly, when to buy ATA. Automata Network is a decentralized service protocol that provides middleware-like traceless privacy services for dApps on Ethereum and Polkadot to achieve privacy, high assurance, and frictionless computation. The issues Automata are seeing are compromised privacy arising from the transparent nature of blockchain, high upfront opportunity costs from users' habitual trust in legacy systems, and persistent friction between blockchain ecosystems crippling cross-chain interoperability. Now let's take a look at their technology. With Automata, existing dApps can easily integrate with Automata with near-zero modification. Automata has great compatibility and is not deeply coupled with one specific chain. The privacy features they are offering are powerful: front-running prevention and anonymous voting. For privacy, we need to take a look at their consensus mechanism, where Automata uses proof of stake. Validators become so by staking tokens and provides a reliable state for participants under POS. Validators are responsible for any number of control plane-related tasks, including managing the registration of both staking and hosting nodes, the distribution of work tasks and rewards, and the marketplace for selling and buying computing power. The second type of node is geodes. With Automata Geode, they employ many cutting-edge technologies, including oblivious RAM, to create an isolated, successfully, and shielded environment to conceal data access patterns, hidden even from the geode provider. Matter of fact, geode can already be deployed on the cloud and existing technical infrastructure. Hosting a computing node is simply as easy as running a validator node on the blockchain. Now let me tell you about the planes that was mentioned before. Automata validators and Automata geodes interact with each other across three planes: control, compute, and service. Each plane serves a distinct and important function. The control plane is the coordinator. The validator maintains a copy of the protocol state, so that geode can receive new tasks and report their status. The compute plane is the executor. This is where geodes can complete scheduled tasks and submit proof of execution. The service plane is user-facing. Vendors can develop and run applications in geode without actually hosting the geode itself. When it comes to voting, Automata created Witness. Powered by Geode, Witness is an off-chain anonymous voting service which allows users to hide their identity and preferences. When users can create proposals and submit votes without having to grapple with the ramifications of exposed privacy or identity leaks, the project benefits from having more input and representation from its community. So to sum up, validators runs the protocol, house keeps the control plane. Geode, computing nodes, accepts and executes work tasks. Geode provider is the physical host that runs Geode. Geode attester runs remote attestation protocol to verify Geode. Now let's take a look at Witness's features. Witness is low cost because voting is conducted off-chain, so there is no gas cost, and a wider range of token holders can participate in governance without being deterred by high gas fees. Chainhook: if desired, it is possible to trigger on-chain execution based on the voting results. Chainhook enables calling of the on-chain contract which was registered at proposal creation. Privacy: projects can choose different types of votes with different private levels, these being public, full disclosure of voter address and number of votes; medium, only number of votes; and private, only voting result is published and voter identities and number of votes are not. With delegation, users can choose to delegate their vote to another address. This will further save cost through an off-chain delegation process. Modular: each of these functions can be used as standalone or together. So if a project wants to use Witness as a signaling tool without on-chain execution, that is also possible. Multi-chain support. Automata currently support ERC20 on Ethereum and will be adding support for other EVM-based chains. Example, Binance Smart Chain and Substrate-based chain soon. And the last feature is API voting. Platforms that are keen to enable the privacy feature can also use the Witness API. So what is the voting process? 1. User submits proposal to their Witness project workspace and invites community to vote. 2. Votes are sent to the privacy relayers. Granularity of results depends on the level of privacy selected, can range from fully public to private, where voter identities and number of votes are obscured. 3. If this is an on-chain executable proposal, the result is sent to the receiver contract, on-chain. 4. As a precautionary measure against malicious proposals, a time lock is applied and the proposal can be vetoed by multi-sig signers before the time lock expires. 5. If the proposal is not vetoed, it gets executed. Now let's talk about another core feature of Automata, Conveyor. Miner extractable value, MEV, is a universal problem. On public blockchains, transactions are broadcast to mempools until miners pick them up for inclusion. This means everyone has visibility of pending transactions and can outbid using priority gas auctions over every last bit of profit, such as front-running opportunities. But still, mempools are only part of a wider issue. Block producers also can rewrite transaction orders. This problem is further exacerbated on blockchains, such as Ethereum, where block reordering is possible. So let me tell you about a scenario where this sandwich attack happens. Alice wants to buy token A on a decentralized exchange that uses an automated market maker model. A miner who sees Alice's transaction can create two of its own transactions which it inserts before and after Alice's transaction. The miner's first transaction buys token A, which pushes up the price for Alice's transaction, and then the third transaction is the miner's transaction to sell token A at a profit. Automata has a solution for this problem. Conveyor, a service that ingests and outputs transactions in a determined order. This creates a front-running free zone that removes the chaos of transaction reordering. When transactions are fed into Conveyor, it determines the order of the incoming transactions and makes it impossible for block producers to perform the following. Inject new transactions into the Conveyor output. The inserted transactions bypassing Conveyor is detectable by anyone because of signature mismatch. And delete ordered transactions. Transactions accepted by Conveyor are broadcasted everywhere, so transactions cannot be deleted unless all block producers are colluding and censoring the transactions at the same time. From the DEX's perspective, they can choose to accept either ordered transactions from Automata's Conveyor, which is free from transaction reordering and other front-running transactions, and other unordered transactions, which include front-running etc., that may negatively impact their users. Automata's Conveyor runs on a decentralized compute plane backed by many geode instances. As mentioned, the geode code is untampered with, and the geode data is inaccessible to even geode providers, in which case they cannot act on said data to front-run transactions. Importantly, Automata's Conveyor is a chain-agnostic solution to the MEV issue and works seamlessly on various platforms with zero modifications needed. Another security feature that I would like to mention is Software Guard Extensions, SGX. SGX allows applications to provision a secure enclave that is isolated from the host operating system and kernel. The Automata team is very experienced in security, and with SGX and Oblivious RAM, it is a highly secure network. Intel SGX provides an opaque box which, if implemented correctly, prevents anyone, including the owner of the box, from looking inside. If you want to read about that technology, head over to Automata's website. Well, it may not have a price as of now because it is still in progress on Launchpad. From what we know, 40 million ATA tokens will be distributed at the end of the Launchpad farming period. There is currently 172 million ATA in circulation, or 17%. After the Launchpad end, another 4% will be released into circulation, which will make the price drop. Also, of the 17% that is already in circulation, people who have big bags will probably sell some of their tokens. So what to expect? As soon as the Launchpad ends, and the token is open for anyone to trade, the price will likely spike up and dump. As you can see, I have two coins where you can clearly see what I mean. So if you want to buy the token, what you should do is wait for at least a week after it has been released. Also, don't forget, if you sign up to Binance with my link below, you can save some money on the fees. If you are still unsure about whether you should buy the coin after a week or two since its release, I recommend that you at least wait for Bitcoin to break above $41,000 before taking another look at it. That's all I have for today's video. If you enjoyed this video, don't forget to like and subscribe for more content. And as always, do your own research, practice good risk management, and once again, I am not a financial advisor. With that being said, I'll see you in the next video.